Hey everyone, today we're going to be talking about a really cool concept in computer science called Quines. A Quine is a non-trivial computer program that takes no input and produces a copy of its own source code as its only output. Sounds pretty interesting, right? Let's dive into an example to see how it works. Here's a simple Quine written in Python. Take a quick look at this one-liner and try to piece through what it is doing. Before we look at how this works in detail, let's run it to verify that it actually meets the definition of a Quine. Firing up an interpreter and running this snippet shows that the output is exactly the same as the source code. Because we also passed no input, it satisfies both conditions and therefore is a Quine. At a high level, this program defines a string that contains the entirety of the source code and then prints it out. This is pretty counterintuitive because how does the program contain the entire source code and then call a print statement afterwards? When first trying to write a Quine, it often seems like you are always so close yet always so far to replicating the source code correctly. This problem is often solved by cleverly using language-specific tricks, such as the format string used in this Python example. So how exactly does this trick work? First off, we have a foo variable being defined to hold a string that contains almost an exact replica of the source code. The only thing it's missing is its own string definition. However, there's a format string being used specifically with !r. This represents a conversion flag that will be parsed by the string's format method. It tells Python to apply the repr function to the argument passed to format before injecting it into the string. By definition, the repr function returns a printable representation of an object. In this case, we'll be calling repr foo, which will return the foo string enclosed in quotes and with its special characters escaped. This is exactly what is needed to create the Quine and is quite an elegant solution. Now this was a very simple example of a Quine, but they can quickly get orders of magnitude larger and more complex, especially as you begin using more verbose languages. In fact, Quines are possible in any Turing-complete programming language thanks to Quines' recursion theorem. We don't dive into that in this video, but I'll provide a link in the description if you want to learn more about that theorem. Here's another example in JavaScript that is very similar to the first Quine. As we can see here, it's essentially using the same structure and technique as the Python example. The major difference is that it's using functions specific to JavaScript, in this case JSON, instead of Python's repr. We'll still run it real quick to verify. Pasting the code into my browser console shows that it is indeed a Quine as well. It's important to note that there are a few types of programs that are considered cheating Quines. That is, they're able to self-replicate but are often using loopholes around the true definition. The first example are programs that read their own file contents. This is technically using a file as input, which does not meet the definition's requirements. There's also some functional languages that make use of self-evaluation, so a source file with just the number 1 would lead to the output being the number 1. Another example is using compiler messages. For instance, writing a file with just syntax error as a string could produce an output that only states syntax error, depending on the compiler used. And finally, in some languages, an empty file is technically a valid program, so running that would be considered self-replicating as nothing would produce nothing. The true motivation for understanding Quines is that it can deepen your appreciation for the elegance and power of programming languages. It's a fun challenge to try to develop one, and just the innate idea of self-replicating code offers plenty of intersecting ideas that we will dive into in later videos. I hope you enjoyed this explanation, and I'll see you in the next video. Thanks for watching.